Welcome to lecture 15, 8051 timer programming using embedded C. In this lecture, we are going to be discuss timer 0 mode 1. So timer 0 mode 1, it is a 16-bit timer. So 8051 consists of two 16-bit timer. In this lecture, I am going to be use timer 0. The timer 0, it will work with four modes of operation: mode 0, mode 1, mode 2, mode 3. In the previous lecture, I discussed mode 0. Today lecture I am going to be discuss mode 1. So timer 0 mode 1, it is a 16-bit timer. So this is a program assuming the crystal oscillator frequency, that is we are feeding in between the 18th and 19th pin of 8051 microcontroller. What is the crystal oscillator frequency we are using? 11.0592 megahertz. Write a program to generate square wave of 15 millisecond frequency on pin number P2.3. We are using timer 0 mode 1, so this is 16-bit timer. So this is our objective. For more clarity, so this is our 8051 microcontroller. 8051 consists of 4 ports, 4 into 8, 32 IO pins. I will choose P2.3 as a pin. In this pin I am going to be generate the square wave of the time period 50 millisecond. But for delay calculation, I will take the one pulse, that is a 25, that is 50 millisecond divided by 2, I will get 25 millisecond. For this single pulse, I am going to be generate the delay calculation. Once I will calculate the delay calculation for 25 millisecond, after that I just complement and again run the delay function, sorry, delay program. I will get the 25 millisecond, but you will get off. Again I complement, again I will run the delay program, I will get 25 millisecond high. Again complement and run the delay program, I will get 25 millisecond off, and so on. So you will get the square wave form with that time period of 50 millisecond. So now come to the program. Here as include or EG51H. Why? Because we are using the register TL0, TH0 and TMOD register, which are available in the 8051 SFR. So we had to be use this as include or EG51H as a header file. S bit, it is a single bit, a keyword, or we can call it as a data type to access single bit in the SFR register. Why? Because P2.3 we support 2. This port 2 is available in the SFR register. You want to access this particular pin, you have to be go with this S bit. I will assign the name my bit for P2 cap 3. Now P2 cap 3 is assigned with my bit. Why? Means for subsequent the program where I had to be use P2 cap 3, no need to use this one, a little bit complement P2 cap 3. Instead of that, I use some name as my bit, or you can assign with the A, B, C as your wish. Here I am using one function, that is a sub function I am using, that is void T0 M1. For understanding, I make timer 0 mode 1 delay function. After that, I use this delay function over here to execute this delay. Okay, T0 M1 delay. Once it will execute this one, directly come over here, it will execute this the sub program. So it is nothing but the user defined function. We can simply call it as a user defined function. As a user, you have to be define this function. After that, later on you can use this function with the function name. Now void main, void. Here tmod 0x01, it is very important register to configure which mode of operation, which timer you want to use. You have to be tell to the microcontroller that which timer you want to use, which mode you want to use, with the help of this tmod register only. Then only the your microcontroller understand that. According to that, it will choose the timer. According to that, it will execute the program, and according to that, it will generate the square wave. So tmod, this is a tmod. It is a 8-bit register. It is timer 0, timer 1. The lower byte, it is related to timer 0. Upper 4 bits, it is related to timer 1. Here focusing only on timer 0 mode 1. So because of mode 1, I will make m0 as 1, m1 as 0. So we will get mode 1 operation. C slash t bar equal to 0, because I am going to be generate the delay, or I am going to be perform the timer operation. It will generate the square wave with the help of internal system clock. Here gate also I am making a 0. So as a programmer I configure this as well as this all 0 because I am not using timer 1. Now I convert this binary format into hexadecimal format. I will get 0 1. So 0 1 H. So X represented is nothing but hexadecimal. So I loaded 0x01 into DMOD register. Why I am not used inside this the sub function. Once you configure this one, you no need to change anything. Okay, once you can start the program, you no need to what is that change this team or register. It is fixed until you have to be change the timer or mode. Until that it is fixed. Now while of one, it is an infinite loop. What is the main program I written in that while of one, my bit, that is p2 cap 3 is equal to complement of my bit. If it is 0, now complement a of that 0 now becomes 1. That 1 is stored in my bit. The my bit is nothing but p2 cap 3. So after that, after this the complement function complement operation, I am performing the t naught amount delay function. I used to be generate the delay. Once it will goes to high, that how much time it will stay for high. Okay, it is go stay up to 25 millisecond. Once it will reach the 25 millisecond, n comes to 0. Again 25 milliseconds stay in the 0 value. Next high low, so on. So that once I will execute this one, here only I used to be what is that write the timer programming. Here only what is that I am going to be generate the delay of 25 millisecond. So how to calculate the delay? So there are, this is a 16-bit the timer. There are two registers we are going to be used for timer 0 operation. One is TL0 and TH0. You combine these two registers, it will what is that get the 16-bit timer 0 register. In this only we can going to be load this value according to the delay calculation which we perform. So here, this is a slide. It is very important to generate the delay calculation. The finding the values to be loaded into the timer. What is the value loaded in the TL0 and TH0? It is important. Based on that, it is going to be generate the delay. So how to perform the delay calculation? What is the crystal oscillator we are using? That is very important. 11.0592 megahertz. It is already available in the electronics market. You go and ask, they will give. Suppose you want 12 megahertz, 16 megahertz, 24 megahertz, you can use up to 24 megahertz. You can use this 8051 timer. But in this lecture series, I am using 11.0592. So divide the desired time frequency by 1.085 microsecond. Wow, divide the desired time delay. What is the time delay you are taking? That has to be divided by 1.085 microsecond. How you will get this 1.085 microsecond? You have to be divide this frequency by 12. Why it is a 12? The inside 8051 there is a divided by 12 circuitry is there. For one machine cycle, usually what is the time it will take? 11.0592 divided by 12. What is the frequency you are getting? That frequency you take a inverse, you will get one time period. That time period is 1.085 microsecond. Usually for assembly language program, for example move a comma b, it is an instruction. So how much time it will take to execute, they define with the help of machine cycle. Okay, they will not tell us 2 microsecond it will take to execute. Don't use like that. They can use simply, they can use how many machine cycle. Okay, machine cycle, machine machine cycle it will take to execute that particular function. How to calculate that machine cycle? You have to be divide this value divided by 12. Machine cycle calculation have to be divided by 12. Okay, you will get 921.6 kilohertz. You take a inverse of that frequency, you will get 1.085 microsecond. So one machine cycle is equal to 1.085 microsecond. So now I want to get the time delay for 25 millisecond. Why? Because I am going to be generate the square wave of 50 millisecond. but I want to what is that, calculate the delay for one pulse. Okay, one pulse. Here I shown already. For one pulse I am going to be generate. Once I calculate this pulse, after that with the same the delay function, just complement that pin, the same delay function I will run, same 25 millisecond going to be occur over here. That's why I just calculate the delay for only 25 millisecond. Okay, for example, if they give square wave, you have to be divided by 2. What is the time it will get? You have to be divided by 1.085 microsecond. So is equal to 23,037 you will get. So 23,037 multiplied with 1.085 microsecond, you will get 25 millisecond. That is the meaning. I want 25 millisecond. You have to be divided by 1.085. So this is the value I will get. So had you multiplied with this, you will get 25 millisecond. Yeah, just cross multiply it, you will get 25 millisecond. Now, how to find out the EXA value which will be loaded in the TL0 and TH0? Yeah, here we downloaded, divided the desired time delay by 1.085 microsecond to get n. So we calculated. So that is the n over here. So why I am using 65,535? Because we are using the 16-bit timer. Timer 0 mode 1 is a 16-bit timer. So maximum value have to be taken 65,535 subtracted with the n. What is the n we obtained? 23,037 and plus 1. Why plus 1 means once your timer reach the FFF, again it will come to what is that initial value. Okay, 0000. That's why you will take one more machine cycle to reach from FFF to 00. That's why I make plus 1 I added over here. So you can subtract and add, you can get 42,499. So it is a decimal value. So in TL0 and TH0 we have to be load the hexadecimal value. So convert this n, that is 42,492 to hexadecimal number. So you will get A5D1. So this is lower byte, this is upper byte. The lower byte I loaded in the lower byte I loaded in the TL. I made mistake over here. Here it is a D1. This is A5. This is A5. Okay, lower byte I loaded in TL0, upper byte I loaded in A5. So this is TL0, so this is TH0. Now come to the program. Here I made mistake. Here it is TL0 only, D1 A5. So A5 D1. So A5 D1. Yeah, final is fine. So here TL0, it is a D1, TH0 A5. Fine. Now you come for the delay function. You have to be load TL0 with D1. So the D1, TL0 is a D1 that is loaded in the TL0 register, and A5 it is loaded in the TH0 register. Once you load, you have to be start the timer. Okay, as a programmer, have to be start the timer. There is a no what is that, the controller will not automatically will not start the timer. As a programmer, you will start the timer. TR0 is equal to 1. Once this timer gets start, your it will going to be the register, whatever the value you loaded over here, from that it is start going to be increment. For A5 D1 is loaded in TL0 TH0. Once start the timer, it will increment by A5 D2, the next A5 D3, A5 D4, A5 D6. What is the time taken between A5 D1 to A5 D2? It is 1.0852 microsecond. Because this timer operation, your microcontroller will take the internal system clock. So that's why for one event, for one increment of that register in the TL0 TH0, it will take 1.085 microsecond. So when it will get overflow, what is the maximum value we can reach with TL0 and TH0? It is FFFF. Once it will reach the FF, this TF0 bit is going to be 1. It means that overflow occur. Once overflow occur, again it will going to be 0. This will automatically the TL naught and TH naught, it will going to be 0 0. So again you make, here you have to be checked while TF naught is equal to 0. Keep on check whether TF naught is equal to 0 0. TF naught is equal to 0. So until that the programmer has to be stay over here. Why? Because it is going to be count from D1, D2, D3 until FF. This becomes 0. Once it will reach FFF, this big is going to be 1. Once it is 1, the while it is come out of the loop, again you make TR naught as 0, TF naught as 0. Again come back here. Okay, my byte, again complement my byte, again it will go for t naught m1 delay function, again it will go for the delay function, again you can load the value. Okay, it is not to what is that load only once d1 a5 in tl not th not, it won't. Okay, it only once only is going to be load, again run the timer, once get overflow, again you make tr not equal to 0, tf not equal to 0. Why? Because it get overflow, it is loaded with 0 0 0 0. But what is the value you want to load to get the 25 millisecond delay? D1 A5. Okay, so this is D1 A5, that is A5 D1, you have to be load. How to load? You have to be, again you can execute this delay function, again this value is loaded with TL0, A5 is loaded with TH0. Earlier it is 0 0, you have to be load. For that you can execute this program again once, you have to be start the timer. Again with this line it has to be stay until TF not equal to 1. So condition get failed, I come out, again you make TR not equal to 0, TF not is equal to 0. This is the programmer's handle. Okay, I hope you understand. This is the header file. Yes, bit my bit 2 cap 3 only, I am going to be generate the square wave with 50 millisecond and writing the user defined function to write the delay program void main. So I will configure tmod register as timer 0 mode 1, and I write this program statement that is inside the while loop. So it is infinite loop. So your microcontroller is going to be generate the square wave keep on until you are going to be switch off the microcontroller. After that I return the delay function. Whenever I execute this delay function, come over here, you will execute. Once it will execute, it create the delay of 25 millisecond. Again come over here, it complement, earlier it is become 1, now become 0, again delay function. So the 0 has to be stay for 25 millisecond, again come over here, 0 becomes 1, again it will execute the delay function, so it will stay for 25 millisecond in the on, so on it will function. Now I am going to be demonstrate with help of Keil, you can able to understand very clearly. Why I am going to be start with how to create a project. Why? Because you have to be set the frequency and all, that's why I start with the initial. The previous lecture I just copy and paste. Here I am using T1 M0 M0. Okay, that is a file name. Timer 1, sorry, timer 0 mode 1 we are using, that is a file name. Okay, fine. I am going to be choose the controller 89C51, that is a controller I am choosing. Give okay, just give no. After that you can open the window, you have to be paste that program. I'm going to be save this one, save the same folder, same name, your wish. I use D0 M1 dot C. Okay, this is the same program I'm using. I make it as T0. Okay, I say .c extension. Now I am going for add that program, add existing file. So here T0m1.c extension only I am going to be add, close. So this is a project name. I selected this is a 89C51 microcontroller. Under that I am going to or is that write the program t not m1 dot c extension. Okay, you have to be tell to the controller that it is assembly level programming or C programming. So with the help of that dot c extension, now I am going to be run this one, zero error, zero warning you are getting. After that you are getting target your the target you are burn your code. After that you are going to be, what is that, the rebuild it. Now you going for this target option, you have to be here, you have to be carefully change what is the crystal oscillator frequency you are using. Why? Because for this frequency only we calculate the delay, so that frequency only had to be you need to specify over here. So just click OK. Again I go for the run option, I am giving OK. So now I am going for the logic analyzer, because here only I am going to be generate the square wave. So go for setup. Here there is a icon, you can just click this one. So P 2.3 only we are going to be generate the square wave. You can specify over here and click close. Now I am going to be run this one. So here 0 to 255, you have to be change the 0 to the transition between 0 1 0 1 0 1 so on. So that's why, so I'm getting, so you have to be zoom out this one, you can able to, yeah, fine, you can get the square wave, but you have to be calculate whether we are obtaining the actual delay or not. Whatever the calculation we done, that the delay we are obtained or not, you have to be checked. You have to be use this signal information and cursor, just you click and you will get this cursor button and you can place over here. Yeah, fine, until here you will get the delta, you will see, you will get the time period of 25.44 millisecond, but actually we want 25 millisecond, but 0.44 millisecond it is coming, what is that, extra. Okay, fine, somewhere it is, here you see it is a 50.24 millisecond. So we obtain the correct the millisecond. We can generate the delay with the help of 8051 timer. So anyway, there is 0.1 or 0.2 tolerance will be there. Okay, no need to worry about that. We'll get almost 99.9% we can generate the delay of 50 millisecond. You can just see the last you will getting the 19.9041. Actually 20 hertz you have to be create, but we got around 19.83. Have to be keep on cursor, fine. Delta value will get 50.24089 millisecond. So we obtain the exact time delay with the help of timer 0 mode 1. Thank you. The next lecture I will catch up with timer 0 mode 2. Thank you.